Good day and welcome to our next Hangout on Air where we're looking at secondary indexing today and multidimensional scaling. So today I'd like to introduce Siri, our engineering manager in the Bangalore office, who's going to talk to us and present and show us a little demo, and Matthew Ravel, our developer advocate over here in the EMEA. During the Hangout, if you have any questions, feel free to ask them during the Q&A toolbox in the YouTube channel. And if you have any other suggestions for topics, feel free always to drop us an email, community@couchbase.com. So right now I'm just going to hand over to Matthew and let him take it from here.
Hello, thank you very much, Laura, and thank you also, Siri, for joining us all the way from Bangalore. So this is a truly global call today. No doubt we've got people joining us from around the world to watch, and we also, we're also quite spread out. So Laura and I are in the UK, and Siri, tell us a bit about where you are today.
Oh, I am in Bangalore and it's 6 p.m. now. So it's been an interesting day today now that the release is coming to a close. So looking forward to the release and looking forward to seeing how customers use the product.
Great. Okay, so thanks for joining us. Like I say, so over the past month and a half or so, we've spoken to people from around Couchbase about Couchbase 4.0. And primarily that's been around Nickel as the query language itself. So we spoke to Todd Greenstein, who's the project manager of our SDK engineering team, and we spoke to Gerald, who is the architect of Nickel itself. But Siri, you've been working on the indexing side of things more. So tell us that anyone who's familiar with Couchbase Server and mobile, in fact, will know that there's already a view-based indexing engine in Couchbase. But you guys have been working on a new secondary indexing method for Couchbase. So tell us what's different and why we needed a new version of indexing for Couchbase.
Sure. So views is a general purpose solution that we have. It covers a broad range of use cases. You could use views to write custom logic in JavaScript, so it's a programmability interface. You could use views to do map reduces, so you can do grouping, you can do aggregations. You can also use views as an access path. So if you look at Couchbase, the key value store APIs, you can reach out to a document using the primary key. But oftentimes you need to reach to the same document through a different attribute. We call this as a secondary key. Typical example would be if I had a user profile and the primary key for the profile was a username, but I wanted to look up someone by their email address. Accessing a user profile whose primary key is the username using their email address is what we call as a secondary access path. View engine can do it. However, we want to do it much more efficiently. And in order to do so, we need to narrow down the scope of the feature set. The problem is that when you have a product that has a lot of features such as JavaScript and other capabilities, it's very difficult to make it perform at the same speed of KV, because KV has been optimized to be blindingly fast, and we want something that can get close to that speed. And so we started the secondary index project. The secondary index project by definition has only one goal, which is to offer a new access path to the data that you already have in your KV store. So whatever you could do through the primary key, we want you to be able to do that using the secondary key as well. There is no programmability, there is no reduction. It is a very small subset of what Views does today, but it aims to do it at a much higher performance point.
Okay, great. So whereas key value access is, like you say, very fast and cached and so on, the view side of things is optimized for something different. It's optimized for giving you flexibility in terms of extracting information from the raw data you have in your JSON documents. And the secondary index is engine, which we're calling GSI. Is that right? Global Secondary Indexes.
That's right. Yes.
Much more focused on just doing one job, so of giving you another index on some portion of the JSON document that you're storing. So Could you maybe give me an example of what sort of an index you might create using our new GSIs, Global Secondary Indexes?
Sure. So if you look at our travel sample, which I love because it's so realistic and it represents a data set that has various structures in it, you may want to look up an airport by the city name, and you may decide to set the primary key as the ICAO code of the airport. Now, what if you want to look up all airports that fall within a certain latitude or longitude? Or what if you wanted to look up an airport by the zip code? Or what if you wanted to look up airports where a particular flight lands? So when you decide the organization of your data, you need to decide what is your primary key. This is the same with all databases, even relational databases. You choose what is your primary key, and that becomes your primary access path. Now, if you look at MapReduce systems, the way to get to data based on filters or conditions that apply to non-primary attributes was either to go through the entire data as you would do in Hadoop or a MapReduce setup, or to build an access path that gets you there through an alternate channel. This alternate channel is what we call as global secondary index, and it is created using the create index statement. So if you are running a nickel query and you wanted to look up an airport by zip code, you can do it without a secondary index, but it's going to take a long time because it has to go through every document that exists in the bucket and find the matching documents. So we call this as a primary index scan. If you know that you're going to be doing this often, then you create a secondary index on the zip code. So the two characteristics of the secondary index are that it is referring to a subset of the document. In our case, it's the zip code, and it doesn't need to be unique. So I could have multiple airports in the same zip code. Whereas for the primary key is always unique. So if I chose ICAO code as the primary key, I couldn't have two airports with that. So the scan of a primary index or a lookup of a primary index always yields a single object, 0 or 1 object. But a lookup of a secondary key can yield multiple objects. And this is another distinguishing factor between primary and secondary keys.
Okay, and the primary key is really just the standard key that we're used to in KV Couchbase, and then the index runs across that. Okay, so indexes. So with Nickel, obviously we're doing SQL-like queries on JSON documents, and by the sounds of it, if you don't set up a secondary index that supports the query you're doing, then you're doing the equivalent of a table scan across all the documents, and so I'm guessing that's going to be quite inefficient.
That's correct.
Okay.
So you're basically making a choice between. So let's say I run a query and I run it only once a year. Then it's not probably important that we optimize it. It may be, but you do have queries that you want to run once in a while and you don't really care about the performance of it. So for that, primary scan is adequate. When we create a secondary index, we are basically incurring a small bit of extra work for every mutation that we do into the KV store. And in return, we get to accelerate the queries that are accessing it by that attribute dramatically. I can show you a demonstration of it, a very simple demonstration of how index would work later in the session.
Yeah, that'd be great.
Sure.
So tell us a bit more about the architecture of the way that you guys have created the secondary indexing engine.
Sure. So maybe I can share a slide to go over the architecture. Please give me a moment.
Sounds good. And just while you're getting that up, has this been quite a global effort, or has it very much been based in our Bangalore office?
So it has its origins in the Bangalore office. So we were sitting around a table and we were thinking about all the use cases, and then we stuck on the idea that this is something that we will need sooner or later. But as the project picked momentum, I think we have had involvement from our various offices. Right now, the architect of the product, John Liang, who spoke to you yesterday, is both based out of Mountain View. Several of the key developers are based in Bangalore. and we always move around, and so as time passes by, we do get distributed between the geographies. It is definitely a
Right.
global effort to build a global secondary index. Are you able to
Right.
see my screen?
Yes, yeah.
Okay. So, maybe is it a reasonable time for me to talk about our multidimensional scaling as well?
Sure. Let's hear all of it.
Okay. So, if you look at Couchbase 3.0 or 2.0 or any of the older releases of the product, every node looked like every other node. There was no distinction between different nodes in a cluster. They were identical. The advantages with this are it's simple to maintain and it's simple to understand the architecture. But a disadvantage is that not every service in a database is suited to run on every node of the cluster. So one of the strengths and the weaknesses of View Engine is that View Engine runs on every node. This means that View Engines have access to the local data on a node, so insertions are very quick. But in order to query an index, view index, you would need to go to every node in your cluster. We call that a scatter gather. And scatter gather is very expensive. So the performance characteristics of view engine is fast insertions and slow queries. So with GSI, we wanted to turn that equation around. And maybe not even turn it around. We wanted to speed up both of them. So we want to do insertions at a reasonable clip. And we want to do queries very quickly. So this means that we cannot shard the index and spread it across all the nodes. And we came up with this philosophy that data scales out and indexes scale up. What you see here on the screen is an illustration of this concept. So we have different nodes. And when you set up a node, you can assign a set of services for that node to support. On the screen, you see that I have 3 nodes which have been earmarked for data. These are the nodes that contain the KV data and basically hold the bucket contents. We have one node earmarked as a query service. This is where Nickel engine runs. And we have 2 nodes earmarked as index services. This is where the global element of index comes in. So we take data from all buckets, all the nodes that you have. And we have a component called projector, which basically extracts only the relevant information and only when necessary. It shrinks it down to a small network packet and sends it to the nodes that need to know about that mutation. And these mutations are now efficiently built into a single index on the index node. So while this is new for Couchbase and perhaps new for distributed databases, the concept has been there for a very long time. You always have index servers and you have data servers. In fact, this concept dates back even to library, hundreds of years ago. When you enter a library and you want to find a book, let's say there are 6 floors in the library. It's very inefficient to go to each floor and look at each rack looking for the book that you want. So you would typically go to a card folder. A card folder represents an index. It's a compact representation of the attributes of the book, such as author or title or topic, are made available to you in physical proximity. So once you go to the card folder, you have access to every book that exists in the 10 floors of the library, and you can look it up there, you can cross-reference. And once you have identified the books of interest, it gives you an access path to the book. So it says go to the 4th floor, go to the 3rd rack and look at the 2nd shelf there. So it is very efficient, but it is also central in nature. So this was the observation that indexes are central and data is distributed. And we modeled the architecture to fit this paradigm that we came up with. We call this as multidimensional scaling because the nice thing of doing this is now I can add index nodes independently of query nodes and independently of data service nodes. So if I'm adding more data to my cluster, but my index has sufficient bandwidth and space, there is no reason to add more index nodes. I can add more data nodes. Alternately, if I started off with an application where I defined 5 indexes, but now I'm planning to double the number of indexes, I may want to add more index nodes. So I can dynamically change the change the allocation of hardware resources to each of the roles in the database server. This is a powerful concept that we know will address a number of customer use cases based on the feedback we have got in the prior releases of the product. We know that customers know enough about the data that they want to control these knobs independently. And with the multi-dimensional scaling, we have provided this service.
Does that mean then that so one thing I perhaps didn't quite pick up on there was whether the index. So in your example, there you had two index servers. Do they both have the same index, or do they have 50% each of the index, the total index?
It's a choice that we provide the user. So normally we expect an index to be on one node. And the reason is that an index is usually a very small subset of your data that we are capturing. And what we store alongside it is an access path. So by and large, index is a much more compact structure than the data that exists on your nodes. As a result of that, the most typical implementation that we expect to see is that our index resides on a node, but we have the ability to partition the indexes. So it might be convenient for a particular use case. So if you are a global organization and you have various data centers, it's probably not often that someone in India looks up information about somebody in United States or vice versa. So it may make sense for you to put a single logical index on two different servers that are probably geographically close to the users. So the create index statement that we utilize to build GSI indexes supports a where clause. So we have a flexible way of supporting what section of the data that you want to represent in an index. Internally, we see them as two independent indexes, and there is intelligence in Nickel to figure out which partition to go to. And as we release further versions of the product, this is one of the areas we expect to do a lot of work in adding intelligence to query processing and execution to utilize these indexes efficiently. The second portion of the question, Matthew, which is basically about indexes and replicas. So we know that a lot of our customers run 24/7 operations and they cannot take any interruptions. So we want to have some kind of redundancy in indexes as well. What we have done in the upcoming release is that we have intelligence built into Nickel to understand that if I have two indexes that can fulfill a query, Nickel can use either of them and it will intelligently choose them based on the load. So I can create two indexes that give you similar information. And what will happen is that these indexes will receive a portion of the load, so they are load balanced. And if one of the indexes goes down, once the cluster manager decides that the node has gone down and decides to fail over that node, Nickel will automatically start using the other node that has an index that can also fulfill the query. So we have some bit of intelligence built into the query side of things. The control that we provide to the user is how they partition the data, how many nodes they want to assign to a role, and where they want a particular index to be presented. The intelligence we provide is to utilize the partitions and the indexes that the customer created in the best possible manner.
Okay, great. Yeah, because I think that was at the forefront of my mind was how do we deal with availability. So thanks for addressing that.
Sure.
Okay, so that's multi-dimensional scaling. But what about the actual indexes themselves? You know, in the indexer, you know, can you tell me a bit more about how the architecture of those really? You know, how we store in the indexes, how are we making sure that the indexes are speedy?
Sure. So in the upcoming release of the product, we're introducing our storage layer called ForestDB. As you know, so far the storage in Couchbase has been CouchStore, which is a great product, very robust and very reliable. But as we go through different kind of hardware itself has been evolving. The nature of the modern hardware and especially the introduction of solid-state disks opens a number of opportunities for us to optimize that were quite not there when CouchStore was conceived and built. So we have a new storage layer called ForestDB, which is a modern and innovative approach to doing storage. So secondly, Forest DB is what we call as a HB trie. We can think of it roughly as a tree where there is prefixes are compressed. So if I put in two strings which look identical in the beginning part, so let's say I put uh, hello and hi, the common prefix which is the letter H is shared, and at the point where they diverge, they break into two different parts. So it brings in efficiency of storage. So when you have a lot of repeating data, which is typical in indexes, we don't store the repeated prefix every time. It is also a modern storage in that it tries to optimize for solid state disks and other newer devices on the market. And this is our primary storage. As architected, we intend to have number of indexes in the future. So right now in the first version of the product, we have a simple binary tree, and that is the most primitive index that one would build. But as we iterate, we have a lot of plumbing built around the indexing area. So our focus will be adding different index types. So we might add a bitmap index, and the bitmap index is very efficient when the cardinality of the matches is small. We may add a bloom filter, which is very efficient at telling whether a particular key exists or does not, probabilistically. We may add associative bloom filter. So basically the indexing effort is going to split into two. One of building the infrastructure and optimizing it, and one of building creative indexes to expand the scope of what is available to the customer when they want to solve a particular use case. So that's how we are going, and Forest DB is the first of our storage.
Great, thanks. Laura.
So I just want to remind people, folks that are viewers watching right now, if you do have any questions, feel free to just type into the questions and answer box, and we will get to it over the course of the talk. Thanks.
Thanks, Laura. So Siri, I wonder if now is a good time to go into that demo that you mentioned.
Sure, yes. Let me share my screen. I'll quickly show you the setting up the indexes and multidimensional scaling. Please give me a moment. So Matthew, can you see my screen now?
Yes.
Okay. So I'm running a 4-node cluster on my laptop. We have this handy script that starts up multiple Couchbase instances that we utilize all the time in testing. And you see here that it's running on this non-standard port 9000. That's because I don't really have 4 boxes sitting here. I'm just running them all on my own laptop.
Right.
And the 4 nodes are running at port 9000, 9001, 2, and 3. So this is the basic setup screen. So I'm going to go here. And when I click setup, one of the first things that you may notice is the new elements on this screen. So we have something called services now, and we have 3 choices: data, index, and query. So these are the 3 multidimensional scalable services that we are introducing in the upcoming release of the product. So let me uncheck index and query. So the first node, I'm just going to set up a KV store, a key value store, which basically holds the bucket data. And I'm going to load travel samples just to play around with it. I don't need replicas. I'll turn it off.
And anyone who wants to try this for themselves can download the Couchbase 4.0 beta from couchbase.com. There's fairly clear links.
That's right. And the product I'm really looking forward to bringing out. But you see, I have a cluster now. I have a single node, and I have my travel sample bucket with the data on it, and it's loading. So far, I think the only difference that we saw is the services checkbox. Let me do something little more exciting. So I'll let me add a server, and I'm going to pick the next server that I set up, 9001, and I'm going to assign nickel to this node. So the second node that I'm adding is going to only serve nickel data. I can mix and match, But typically our sizing guidelines and the application's business use case determines what is an ideal setup for a given set of application use cases. My data is still loading.
Okay, so I'm guessing when you add only a query node, you don't need to do a rebalance, or do you?
So it's strictly not necessary to do a rebalance. So the whole notion of a rebalance operation is to let the cluster manager know that a new node has been added. So it doesn't move data around between the nodes, but it does, however, inform the cluster manager that this node has been added to the cluster and gives it appropriate privileges and permissions to access the machines.
Mm-hmm.
Okay, now that the data load is done.
Yep.
Yeah. So I have created the index and the data buckets, and if I go to the server nodes, you see the services clearly shows that the 9000 node is running data and 9001 node is running query. And of course, I'd want indexing nodes, so I'm going to pick one node.
So something that comes to mind for me at least is when having different types of node within a cluster it sounds complicated. It sounds like it's going to make the life of the operations people more difficult. But watching you set this up, it looks like it's a fairly typical Couchbase add node process. You're just typing in the IP address, the password, and so on, and then it's just a checkbox to choose which type of node it is.
That's right. And we also give the option of running all services on all nodes. So if you are doing a small rollout or if you are just playing around with the product, you don't have to use multi-dimensional scaling. You can run every service on every node. So you can have a homogeneous cluster. But Matthew, what we have seen is that when you have a significant rollout and you have production data and you have traffic coming in, invariably you want to have more control over your cluster. You want to be able to size different attributes dynamically, and that's when the power of this multidimensional scaling comes in. To summarize, you don't have to use it, especially if you are doing a proof of concept or a simple application, but you have it available to you when it is necessary in a production environment.
Great.
Okay, and here is a new dialog. It asks you for the RAM quota. Just like you can specify how much RAM the bucket should use, you can do the same thing for index as well. So I specified that it will use 256 MB, which is the size of the buffer cache. So here we go. So I have my cluster set up. I have a data node holding my travel sample. I have an index node, which currently has nothing in it. I have a nickel node, which is now ready to serve the request that I'm going to send it. If I go to indexes, you will see that there's nothing here. So there are a number of ways of accessing the nickel, and I'm sure the nickel Hangouts would have gone over it. I'm going to use my favorite, which is the command line interface. I'm going to run cbq, and because I'm running in a developer environment, I need to let cbq know where to connect. But in a normal installation, the parameter is not necessary. You can just run cbq and it will be ready to go. So let me do something to make sure it's working. Okay, it can add 1 and 1, which is good. So I'm going to execute a simple select statement. So let me do select count star from travel sample. And I get a count. Now let me do so I could do a count because nickel can do a count on the bucket. So it is intelligent not to go through all the documents and try counting them. But when I tried to do a little more complex query, Nickel basically told me I have no way of accessing documents where the ICAO code is KSFO. So it's basically saying, I don't know how to do this. You need to give me an index to iterate through documents. And the specific message you see on screen is create primary index to create one. So what Nickel is saying is right now I have access to only the bucket and I can access the documents in bucket knowing the key, but I have no way of iterating through every document in the bucket. And so I need a way to do that. And so
presumably we don't create this automatically because people might not want it, and that would be a waste of resource each time it created the index.
That's right, yes. So our approach always has been that if you have a use case that's working well, nothing that we do in the coming versions should break it in any way. So if you upgrade from 3.0 to Sherlock to the upcoming version, that's our internal code name Sherlock. It will work identically the way 3.0 did. So we create no new indexes. We do not spawn any of the new services. And we do so only when specifically configured. Yes, and that's the reason why we don't create a primary index. But now in the brave new world of Nickel, you will almost always want to have a primary index. So let's create one. So I'm going to say create primary index on travel sample. So a couple of notes.
We've lost your screen sharing there.
Oh, okay. Sorry. Can you see it now?
Yeah, we're back.
Okay. So the statement that I'm executing is create primary index on travel sample. So primary index is special because we consider the ability to go through every document in a bucket as a very primitive operation. So it gets its own statement, and that's the primary word on the create index statement. And the other point to note is a primary index has no identifier name. Because it's a primary index, it doesn't need a name. So let me go ahead and create that. And it's done. So now I have created a primary index and travel sample. If I flip over to my console and I look at my indexes, you see I have created a travel sample with the definition create primary index, and it's up and running on node 9002. Now let me show you multi-dimensional, and before that let me just give you an example. So I'll run the query I tried just before. So I'm trying to look up a particular airport by the code of the airport, San Francisco Airport, my favorite. So the last time we did this, it complained and it wouldn't succeed. Now the query succeeds. So it's able to pull out the San Francisco Airport, and you will see that the ICAO code is KSFO as specified. But you did notice it took some time. It took 2.37 seconds specifically. And let's see why. So Nickel has this handy explain statement. I just take the statement that I ran and put an explain in front of it. And I think if you look at this long enough, you will get a gist of what this is trying to say. But it's effectively saying that it is going to scan every document in travel sample and then look for a condition where the code matches the name of the airport. And that's the reason why you see, so it took 2 seconds. I'll run it once more, even though now more things are going to be cached. It's still going to take some time because it has to run through all the documents in the bucket. It still took 2.9 seconds. And here is where secondary indexes come in. So now I'm going to create an index. Oh, before that, let's say that my bucket happened to be very large and I didn't want to use the same index node to hold my secondary index. So my primary index is on node 9002. So I'll go to my cluster administration and I'm going to go to add server and let me add one more node. And I'm going to earmark this as an index node as well. click rebalance. And at this point, the cluster is set up, and now I have two index nodes. And I have my index that I just created on node 9002. So now let me create the secondary index that I was interested in. And this is going to look like this. I'm going to say create index, and I'm going to give it a name. Let me call it ICO index. So does this look obvious, Matthew?
Yeah, so you're specifying the bucket and then the JSON key within the document that you're looking to create the index on.
Exactly. And that's one nice thing about Nickel is it's pretty easy to see what's going on. So I create a new index called SEO index on the bucket travel sample, and on the field ICAO. So the create of the index is going to take some time. You will see that the create index was itself not cheap. Creating the index took 2 seconds. But let's see what we get for it. So I'm going to run the select statement that I was running just before. And you'll remember this select statement used to take 2 seconds. And there you go. Now it takes 36 milliseconds.
Yeah.
And I run it once more, and now it's taking 3 milliseconds. So it's now 1,000 times faster. And yes, and this is with a very small data set. If I had a real bucket on a real cluster, a primary index may take hours, and a secondary index could return in milliseconds. So it's a pretty significant component of the Nickel stack. Okay, I think I have been in terminal long enough. Let me go back and show you one last thing.
Okay.
So you remember after I created my primary index, I added a new node and I earmarked it as index node. You will see that Nickel has basically distributed the indexes to the new node. The primary index that I created has gone to node 9002, and the secondary index that I created has gone to node 9003. And it's all transparent to the user. All the user does is run the select statement. Nickel is going to figure out which index to use and go to the right place and do the query there and return the results. And this is how multidimensional scaling works. It's very common for people to write an application. And let's say that now I'm having a sale, so I'm going to look up people based on their prior purchases. So for the next 2 weeks, I may want to create indexes that don't already exist. And if the cluster is not sized for it, you can very easily add more index nodes, create the indexes, and then drop the indexes when you need it, and repurpose this for some other use, for example, as KV or as Nickel node. So it gives you a lot of flexibility and is pretty straightforward to use.
Yeah. Great.
Okay, so I think that was the part that I wanted to show. It's not very exciting because by definition, GSI's only purpose in life is to make Nickel faster. So GSI is one of those things that if you see it working well, then you don't notice it.
Yeah.
You notice its existence only if there's a problem.
Right. Okay, cool. So you have mentioned a few of the things that we might see from GSIs in the future. One that I was wondering about was, will we be able to access the secondary indexes directly outside of a Nickel? You know, so in the same way that right now you can do a query on an index created by a view, would we be able to do just a simple key value lookup on a secondary index outside of Nickel?
That's a good question, Matthew. In this release, we have gone back and forth on whether we want to do it or not. So we realized that now we have two major programming models. We have the key value storage that we had in our 2.0 and 3.0 versions, where you work with objects, you pull them out by keys and store them as through keys. With the addition of Nickel, we now have a different model where you're using SQLX statements to implement your business logic. And I showed you the ability to query documents, but we are also adding the ability, or it's either there or it's going to be there very soon, to also manipulate the document. So we'll have an update statement which will let you write to the document. So now we have two models which coexist with each other. You can use key value if that suits the application, and you can use nickel if that suits the application better. They go against exactly the same data, and they have the same fundamental attributes of the server. The big question for the secondary index team is, will key value use cases want to utilize secondary indexes outside of nickel? It's quite possible that if we want to utilize secondary indexes, it's easy enough to write a select statement to fetch the lookup. So I'll give you an example. So if I was looking at somebody by their email address, I might have set them using the key value, so I might have done a set operation. But if I look them up by email address, I can do a select statement. There is nothing that prohibits you from doing it because the two APIs coexist with each other. And this might be a reasonably efficient way of doing it, but it may not be either. So people may prefer to use the key value access, and they may want to utilize GSI just like they utilize view indexes today. The answer we have is I don't know, and we are waiting for feedback from community. So if our customers and our developers want the ability to access GSI directly through the key value APIs, we are very close to being able to providing it. But if people like to use it through nickel, then it gives us a more compact API and a clearer story. So that's our path that we are following. And this is one of those things that we really hope the community will help us define.
Great, thanks. Just gonna check if we've got any questions from the audience. Martin asks, what about full text search, and how does that relate to GSIs and nickel?
So full text search is not currently part of the server product that we are releasing. As we are investing in indexing as an area, one of the things that we have been working on for the last 1.5 years is full text search that's entirely written in Go. And this is one of those that we are planning to bring out in our forthcoming releases. This is also currently being spec'd out. Full text search is a product offering in itself. It has a lot of complexity and richness, and it has various touch points. One of the touch points for full text search is obviously nickel. And just like you could do the same operation either through KV or through nickel when it comes to a secondary index, there is a parallel for full text search. There are things that you can do such as queries and looking through all the content of a document that does fit well into nickel. There are also aspects such as defining a stemmer, which has no real equivalent in SQL world. So this is one of the areas we are trying to spec out. Our initial goal is to build full text search the way full text search folks understand it traditionally. So there's a long history of full text search products, and Oracle full text search is one that pops into my mind. So the folks who define the space have also set up some standards and expectations on how full text search works. Our first goal will be to try to address that use case and bring in the familiar functionality. Then we look at how it intersects with nickel, how it intersects with GSI in fact, or how it intersects with the geospatial search features. We hope to converge in the very near future. But one key point of convergence is we need to know how customers utilize it, how developers like to use it. And these are things that we can guess, but we really don't know until we put it out and we see use cases of it. So we are waiting for our developer community to tell us how they want us to proceed. If we get a lot of feedback that they like to see them all appear as one unified product, we are very well equipped to do that, and we have architecture in place to make them converge. But if we say that people like to utilize the native interfaces for doing map reduce in views, and they like the interface available in nickel to doing access paths, which is quite a possibility as well, because it's not often that you look at an access path also as a reduction. Then people may be actually happier to have two interfaces that are custom built to address these use cases. So this is one more of the topics that we hope to touch upon in the coming releases, and a lot of what feedback we get in these releases will shape the outcome.
Great, thanks, Martin. I hope that answered your question. Siri, I mean, we're coming to the end of our time now. Is there anything else that you'd like to add?
I'm very excited. I think I'm an old database person, and I learned SQL in my school days. And I really like SQL because it let me tell what I wanted to do without saying how it needs to be done. And it's very common in when humans operate to operate in this manner. You tell how once, but you ask it to be done many times. And so SQL was a very natural fit where you looked at the database as a big black box that could do things for you. And SQL was the language that you used to instruct it. And this was a very powerful paradigm, and I think it was one of the reasons why databases were so successful. With the introduction of NoSQL databases, we gave a lot of flexibility. The prior implementations, while utilizing the strength of SQL, also made it very inflexible by enforcing schemas, for example. So the NoSQL movement, one of the key things it brought in was the flexibility, the ability to adapt to what customers want to do rather than enforcing something on top of an application. And so now we have completed a full circle, bringing a friendly English-like language that is declarative, that helps you do what you want to do without specifying how to do it. So I think it's a very key product release for Couchbase, and I'm really looking forward to see how customers use it and the feedback we get from them.
Great. So I just
Great,
got one more
thanks.
question coming in at the moment. It's from Michael, and he questions is, how does the performance compare to MongoDB?
So I personally don't have that information right now. We have been heads down on making all the core parts of the product work well. We do extensive performance testing. In fact, I just got 4 servers sitting next to me for the precise purpose of doing performance testing. The goal for secondary indexes has been to keep up with our key value store. And as you guys all know, our key value store is the fastest thing that you can find. It is blazing fast. It is so fast that it sets a very tall bar for us, even internally in Couchbase. If you look at View Engine and you look at the amount of data you could pump into key value store, fundamentally, let me take a step back, right? So we have various data structures. Our key value store is effectively a hash table. View engine or a secondary index structure is a B tree. So a hash store is O of 1. It's basically a constant time operation to insert or remove things from it. But in a B tree, it's a login operation. So we fundamentally recognize that the way our system is architected, our key value store can put a much higher throughput than a binary tree can produce. The the thing is, the theoretical aspect is one, but actually optimizing to bring them close is what has been the fundamental reason for building GSI. So I have not been paying a lot of attention to competitor offerings because right next to me I have a very tall bar to meet, which is our Kiwi throughput, and we haven't got there yet in our first version, but we are going to spend the next 6 months working really hard to get there. We have some pretty exciting developments in store over and beyond what we are announcing now. And we are going to close the gap with ourselves in the coming months. And perhaps at that time, our marketing division will have more competitive benchmarks as to how we stack up with our competitive offerings in the space. But right now, my biggest worry is meeting our own KV throughput, and I expect it's going to keep me busy for the next 6 months. And if we can get there, I have a feeling we are going to beat our competitor by a very big margin.
Great, thank you very much, Siri. Laura, I'm going to hand back to you to wrap things up.
So thanks, folks, for taking part in today's Hangout. I hope everybody enjoyed it. If you do have any suggestions for topics that you would like to hear, please just drop us an email at community@couchbase.com. And I just want to show you some activities that's actually happening, maybe possibly in your local area, and how you can keep in contact with us. So just bear with me a second. There we go. So we actually have an event coming up in Paris on the 29th of September. It's called Couchbase Live. It's open to everybody to attend. There's some great talks lined up, and it'd be a great way to actually meet some Couchbase engineers. If you're also looking to find a nearest Couchbase meetup, we have them from London, Paris, Spain, Stockholm, Oslo. We're in everywhere, and we'd love to meet up with you. We've got various topics coming from Couchbase Server and Couchbase Mobile. And if you ever want to hear what's actually keeping up to date, the easiest and fastest way to keep up to us is to sign up to our Couchbase developer newsletter. It comes out once a month. There's some tips and tricks of how you use Couchbase, and also some of the latest blog posts that the developers are actually writing. So.
And also, if you want to meet Siri in the flesh, there's a Bangalore meetup coming up soon, so look for Couchbase Bangalore on meetup.com.
On September 4th, in fact.
We look forward to it.
So I want to thank everybody for taking part. Thank you to Siri and thank you to Matthew. Thanks, folks.
Thanks a lot.